Brittany from New Jersey asks, I took a test that asked for the definition of the term subset. I wrote part of a set and got no credit. I didn't understand my professor's explanation. Who is right, her or me? Help me, Professor N. Brittany, unfortunately your professor is correct. Here's why. Here is the mathematical definition of the term subset. Definition: let A and B be sets. A is a subset of B means every element in A is an element in B. Now this is what your professor was looking for. This is the mathematical definition of the term subset. Let's do some examples and see why your answer, part of a set, as a definition for subset, is actually inconsistent with the correct definition above. Let's look at this example first. Example 1. Is the set containing the elements 3 and 4 a subset of the set containing the elements 1, 2, and 3? Now, for this set to be a subset of this set, as per the definition, every element in this set must be in this set. If you like, we could call this set A and this set B. We have to see, since 3 is in A, if 3 is in B. And it actually is. So we can put a little check mark here. Now let's look at the element 4. So the element 4 is actually not in set B. So this means that the answer to this true-false question is actually false. And let me give you the reason. Since we have demonstrated the existence of a counterexample, example 1 is false. Now, what is this counterexample? This counterexample is the element 4. Now, we have something important here that should be acknowledged. Corollary. In order to show that an example fails to satisfy the definition of subset, it is necessary to demonstrate the existence of a counterexample. Now that's what we did in example 1. Let's look at another example. Here, example 2 says the set containing the elements 1 and 2 is a subset of itself. True or false? Now, we need to check to see if every element in set A is in itself. So let's see. Here's a 1, and here's a 1. All right, that's very good. Here's a 2, and here's a 2. All right, that's very good. So every element in set A is in itself. Now this shows that A is a subset of itself. And this can be generalized into a very important theorem. And I'll call this theorem 1. Every set is a subset of itself. Now, Brittany, this is a very important idea because you defined a subset as part of a set. But here we've shown that from the formal mathematical definition of subset, every set is actually a subset of itself. And this is one of the contradictions that would come out of what you thought was an actual definition. Every set is actually a subset of itself. And this was one of the ideas that I would suspect your professor was trying to convey to you. For all you internet viewers out there, the next video will explain why the empty set is actually a subset of every set. And this also is a contradiction to Brittany's definition that she put on her exam for the definition of subset. So let me give you all a little teaser for the next video. Theorem 2, the empty set is a subset of every set. So stay tuned. If you like this video, subscribe and give us a thumbs up. Brittany, I hope this was helpful, and I hope you watch the next video to come. Thank you all.